How does Gini impurity work in machine learning? Have you ever wondered how machines learn to make decisions? One key element in this process is Gini impurity, especially when it comes to decision trees. Let's break it down in a simple way. Gini impurity is a metric that helps decision tree algorithms determine how to classify data points. It measures how often a randomly selected data point would be incorrectly classified if labeled according to the distribution of classes in a subset. This is crucial for making accurate predictions. At its core, Gini impurity quantifies the impurity of a dataset. If all data points in a subset belong to the same class, the Gini impurity is 0. This indicates perfect purity, meaning there is no uncertainty in classification. On the other hand, if the data points are evenly split among different classes, the impurity is at its maximum. This reflects high uncertainty about how to classify the data. When building a decision tree, the algorithm looks at different ways to split the data based on various features. It calculates the Gini impurity for each possible split. The goal is to choose the split that minimizes the weighted average impurity of the resulting child nodes. This means the chosen split creates groups that are as pure as possible, which improves the model's ability to classify new data correctly. Mathematically, Gini impurity is calculated using a formula. For a node with classes, each with a certain proportion, Gini impurity is computed as 1 minus the sum of the squares of these proportions. This formula reflects the probability that a randomly selected element would be misclassified if labeled randomly according to the class proportions. Gini impurity is widely used in many implementations, such as the classification and regression trees algorithm and libraries like Scikit-learn. It is favored because it is efficient and straightforward. It guides the tree to grow by selecting splits that reduce uncertainty and increase homogeneity in child nodes. Understanding Gini impurity is important in the context of artificial intelligence and machine learning. It shows how decision trees make decisions based on data purity. This concept connects to broader applications in artificial intelligence, including natural language processing models and image generation tools. Moreover, productivity plugins that automate data analysis often relying on metrics like Gini impurity to optimize model performance. However, it is essential to consider the quality and balance of training data when using such metrics. If the data is biased, the impurity calculations may lead to decisions that are unfair or inaccurate. By grasping how Gini impurity works, we can better understand the mechanics behind decision-making in machine learning models. This knowledge supports responsible artificial intelligence development and encourages careful consideration of how data is partitioned and decisions are made within models.